Assalamu alaikum. In our today's lecture, we are starting with analytical chemistry. So, analytical chemistry, the name suggests itself what it means. So, basically, we will do some analysis on specific components. So, specifically towards the organic components, which are contains carbon and hydrogen. So, or we can say hydrocarbons. So basically on them, we will be doing some analysis, sort of identifying them. Now, analytical chemistry could be done in 4 ways. Now, depending on what information we are given or what information we want to extract, analytical chemistry could be done in or categorized in these 4 ways. So one is HNMR, which is one HNMR, that means based on hydrogen, like the first isotope, which is just hydrogen. We have hydrogen, we have deuterium, we have and tritium most probably. So like only the hydrogen with the isotope having the neutron number of 1, sorry, the proton number of 1, that means molecular mass of 1, atomic mass of 1, that is going to be considered here. Then we have CNMR. This is hydrogen NMR. Then we have carbon NMR. So why is it not raising? Just a minute. So NMR, and this is carbon-13 isotope. Based on carbon-13 isotope, we are going to conduct our experiments. Next, we have IR spectroscopy. IR means infrared spectroscopy. Infrared spectroscopy. Finally, we have, let's mark it here, which is mass spectroscopy. Yeah. Mass spectroscopy. Okay, so these are the 4 categories in analytical chemistry we will be observing in detail. Okay, one of them we did saw in our AS. So in our AS, that's one of the spectroscopy, or one of the analytical chemistries followed in detail. So no worries, we will be observing them in this portion as well. So inshallah, everything will be covered. Moving into explaining these terms, what are each of them? Let's see. So HNMR, what does HNMR means? Now, HNMR is basically nothing but it is the way to identify the chemical environment of hydrogen atoms. That means what? That means actually it helps us to identify the total number of hydrogen atoms present in a molecule. That's why it is named as HNMR. So this is basically identifying hydrogen. Identifying H atom based on chemical, so chem environment, ENV, chemical environment. Now the second one is carbon NMR or CNMR, which is, as we can say about HNMR, similarly it's for CNMR, that means is a chemical environment of carbon atoms. Okay, CNMR is identifying now C atom by observing based on the chemical environment. Okay, so that means now the chemical environment of carbon atom. In our third, we have IR spectroscopy. IR spectroscopy. Now, IR spectroscopy is to identify the functional group. Remember, the functional group, we have carboxylic acid, we have alkene, we have alcohol, we have aldehyde, we have ketone, isn't it? So these are the functional groups. So IR spectroscopy is used to identify the functional group. Identifying functional group. And in our fourth number, we have mass spectroscopy. Now this is like this mass spectroscopy's name suggests it's based on the mass. That means this is like a thorough experiment to identify the mass of the molecule. Okay, so molecular mass. So in order to identify the molecular mass, we use this method, mass spectroscopy. Yes. So identify MR, or molecular mass, as well as it helps us to also identify number of carbons, number of carbon atoms, C atoms, and the percentage abundance of the isotopes. Now, what does this percentage abundance of isotope means? That means which isotope is in which portion. Okay, so that means is there carbon 12, carbon 13, like which isotope is here? So that will help us. So percentage abundance of isotopes. Okay, like which species is here, which isotope is here. Okay, because molecules or atoms have different isotopes. Like some atoms have, for example, carbon 12, carbon 13, carbon 14. Then we have hydrogen, hydrogen 1, hydrogen 2, hydrogen 3. So deuterium, deuterium. So these are the like the isotopes part. Now let's move on to our first part, which is HNMR. So we will in the first part, we will be actually describing or observing how HNMR is conducted. Okay. Now, so at first we have to identify the chemical environments. Let's see what does this mean, what this term means actually, the identifying the chemical environment. What is chemical environment? Let's observe that first. Let's say we have this molecule here. So we have organic substance of alcohol. Let's say here we have. Okay. Now observe that for each carbon, like for different carbon, how many hydrogens are there? That means hydrogen bonded with different carbon atoms. What are they? One is which one? This is, you can say, a group, isn't it? Like because of this carbon, these three hydrogens are bonded with a single carbon. So this is a group of hydrogen, isn't it? So you can say this is a single environment, one environment. Then we have what? This is a group because these hydrogens are bonded with this carbon, specific this carbon. So that means this is another environment. Now, based on this alcohol part, every alcohol, carboxylic acid, okay, these are considered as one single environment, okay? One single environment. That means what? In total, how many environments do we have over here? 3 environment, 3 chemical environment, okay? Let's do a couple of more examples to identify what does chemical environment actually means. It's completely fine. If you didn't get it, eventually you will get it. So this was the first example. Moving on to the next example. Let's say another molecule we have, this one. Using the same concept from the first one, just try to make sense that how many environments is present here. Here we have 1 carbon, 3 hydrogen bonded with it, and we have an alcohol group. Did you get it? By try to solve it yourself. Pause the video and try to solve it yourself. So were you able to solve it? If you didn't, so let's solve it together. So this is one of the group because these 3 carbons are bonded with this 1 carbon. So this is one environment. Then we have this alcohol group. That means in total, how many environments? two environments. So two chemical environment. Let's move to the next one. Let's say we have this molecule. Try to solve it by yourself. Pause the video and try to solve it by yourself. So here is one carbon, 3 hydrogen. There is one carbon, 3 hydrogen. There is one carbon with OH here and a Br here. Try to solve it yourself and see if you get it or not. So let's see how many are there. Even if you are not sure, I would still urge you to at least try for once, attempt it. Like if this molecule looks different from the others, still try once, make the mistake, because if you make mistake, you will remember more. Okay. Now, how many hydrogens or carbons? Like, let's see. Here we have this single carbon bonded with 3 hydrogens. So this is an environment. Here we have again 3 carbon bonded with a carbon, like 3 hydrogen bonded with a carbon. Now our main scope is, like, main concern is what? The hydrogen. And based on the carbon, we can do this NMR. Okay, that means hydrogens bonded with the carbon specifically, those are going to be considered. Okay, like specifically in general. But in OH case, in alcohol's case is what? Hydrogen is bonded with the oxygen group. Okay, so that means this specifically is considered as the whole one environment. Okay, the reason we will be describing it in a short while, you will get to the position where we will be able to answer actually how many environments, what it depends or how it matters that how many hydrogen should be considered. So whenever you see just hydrogen, just count it. Okay, whenever you see a hydrogen, just simply count it that this is the environment. This is the environment. Consider that as an environment. Now that means another environment. Now, did you mark Br as an environment as well? Remember, we are just focusing on what? Hydrogen. That means Br is not an environment. Okay, so that means how many environment we got? 3 such environment. Now see, there might be some carbon where none of the hydrogen is bonded with it. In that case, what do? We leave it how it is. So that means that's not an environment. So here we got 3 chemical environment. Okay, let's do some more environments. Let me give you some. Try it by yourself. So CH3, 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 OH. We have, let's say, pause the video and try it by yourself. And we have CH3, COO, CH3. CH3, CO, CH3, CH3, CO, CH2, CH3. CH3, COO, CH2, CH3. Then we have, I would urge you for each of them, pause the video, write by yourself. One hint I can give is, for each of the molecule, you can draw the discrete formula. Okay, you can draw the discrete structure and then try to identify, because displaying them makes it easier for you to identify how many environments are there. Okay, then we have this. Then we have number 10 as CH3, CH2, CH3. Here we have OCH3. Then we do have CH3, CHO, 13, CH3, CO, NH, CH3. CH3, O, CH3, CH, CH3, CH3, CH2, CH2, OH. Number 16, we have C, Cl, 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 C, H, Cl, C, H, H, H. 17, we have C, H, H, Br, C, H, F, C, H, Cl, OH. Okay, try to solve them all. Pause the video and try to solve all of them, okay? Like, it's not possible for me to stop in each of them. So like wherever you are able to see the question, try to pause the video there, see the question, take the or grab the question in your pen and paper, draw it by yourself, see how many environments you find, because we will be actually solving it now. Okay, so we'll be solving it now. Let's see if you like try to solve every of them. Okay, up until how many examples we have been given, try to solve every of them. Don't worry, just whatever you understood, solve all of them. And now like match with my solving to see if you got correct or not. Don't worry if everything like you got all of them wrong, it's completely fine. At least you learned something new. So from here, number 4, we can see what CH3, CH3, CH3 group, like all of them looks identical, isn't it? That means this CH3, 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 isn't it? It looks identical, and we know that each of them is bonded with what? How many hydrogens? This 3 hydrogens is carbon, isn't it? In this case also same, in this case also same, isn't it? Let's draw it completely to make things easy for you. See. And we have OH. Now, most probably, if you have solved it, you have given how many? 1, 2, 3, and 4, isn't it? 4 environments, but this is actually wrong. There is only 2 environments. Now, why is it that? Let's see. At first, see, these are identical, isn't it? Like you cannot distinguish between them. You can observe them what? It's like simply they're completely identical. There's no change in them. And like this is one such, this is one such, okay. And see, they're like this carbon, like this adjacent carbon and the adjacent carbon to that carbon is linked with the other carbon which has that environment, similar environment. That means what? This CH3 is not like that. Let's say instead of here, we have this CH3 over here. Okay, that's not the case, isn't it? It is bonded with the same carbon. That means all those, like all the environments are similar. That means we can mark all of them as one single environment, because whatever way we see it through that like experiment, through that machine, this HNMR is done through some apparatus. Through that apparatus, what like if we do, we will see that we are observing just CH3, like the environment for CH3. That means there is how many environments? One environment for like CH3 because they're identical, and one environment for this OH. That means in total, how many environments do you get? One is here, another is what? Like we can mark the identical which have similar like shape as the same shape. Let's say this rectangular or the square part represents the similar environment, and the circle part represents the other different environment. That means what in total? 2 environments. So 2 chem ENV. Okay, these are identical. Identical. Okay. Now moving on to the next one, we see what? CH3 COOCH3. Here we have CH3 C double bond O CH3, isn't it? Now you might be thinking, okay, then that means this is CH3, this is CH3. Then here they are identical. This is one environment. Okay. So, and no more hydrogen is there. That means we have here one environment. But that's also wrong because here we have 2 environments. Now, why is that? Just previously I told that this CH3 identical CH3 groups are there. That means that's one environment. Remember I told that needs to be connected with the same carbon. If this is the CH3, this CH3 needs to connect with the other CH3s, like the carbon, which carbon should have the same group CH3. Okay, if this carbon would have another CH3, then they both are identical. But since this CH3 was like where? This is in some other part, an other carbon or another portion. That means what? This is one of the group, one of the environment, that's another environment. So marking them with 2 different shape. One is this circular and is this square. That represents what? 2 chem ENV. Okay. Now see how this CH3 COCH3. Let's draw the structure. We have this CH3 here, CO and CH3, isn't it? Now tell me how many environments are there. Now, if you say we have 2 different environments, you are wrong. But if you say one environment, that's you're right. Why? We have this CH3 over here, another CH3 over here, and both the CH3 is connected with which carbon? This carbon, same carbon, isn't it? That means one single environment. I hope you're getting it, like how these things are happening. Like we need a common connection between them. If we have identical groups, then that groups need to be connected with same carbon. This is one of the group. This is another group. Both are connected with the same carbon. That means what? If we observe this in perspective of this carbon, let's say you are this carbon, then for you, this CH3 is also same and this CH3 is also same, isn't it? How will you distinguish between them? Because they don't have any identifier. They don't have any, like, for example, NID card number or any fingerprints. Both are same. Okay, so that means there is only one environment. Now let's come to the next part where we have CH3 CO. That means C double bond O, CH2, or let's say mark it as CH2 and CH3. Now how many environments are there? Remember, this CH3 and this CH3 are not connected with the same carbon here, isn't it? So that means what? This is one group. We can mark it with, let's say, this square shape. This is, let's say, marked with like circle or oval shape because it's in another part CH3. And this middle portion CH2. This is also an environment. So let's mark it with a triangle. So we got what? 3 different chemical environments. So 3 chem environment. Over here, in the next example, we have what? CH3 COO. That means an ester group. CH2 CH3. Now see how many environments? Same as like before. There's the one, there's another one, and there's another one. So that means in total 3, isn't it? 3 chem environment or chemical environment. Let's move to the next one. Before solving 9, let's solve 10. 9 is a bit complex. So 9 is not complex actually, it's actually easy. So move on to the next one. Number 10, we have what? CH3, CH, CH3. Now try this one by yourself. Pause the video for a few minutes or a few seconds. Try the one. See if you can understand, or based on the previous information, did you understood, or did you understand like what are these like atoms are, like how many environments are there? Were you able to answer this? So basically we have a CH3 group here and a CH2 group here. Now see if they are connected with the same carbon. Yes, they are connected with the same carbon. That means this and these are identical molecule. I mean the identical environment. And another environment we have, which is CH2. So we have what? Two different environments. So two chem environment. I hope you're understanding this. Now moving to the benzenes part, let's see how many are there. Okay, we will do the benzenes part as well later. Let's do the other part, like the easy parts. So CH3CHO. So CH3COH. How many environments? Easy peasy. So CH3 and a H group here for this carbon. Like that means what? Two environments. 2 E and V. Chem E and V. Then we have what? CH3 CONH. That means the peptide linkage is there, and we have CH3. Now see, this is carbon. CH3. Also, there is another CH3, but are they like same? No, they're different. Sorry, I also forgot to mark this with different shape. So CH3 and CH3, because they are bonded with different portion, I mean different, they exist in the different parts, not connected with the same carbon. So there are two different environments. Now don't forget that there is this also hydrogen. Remember I told that wherever you see hydrogen, mark it. So here we have another environment for this amines part. So NH, that's the environment. So here we have in total of 3 chemical environments. 3 chemical environments. Let's move to the next one where we have, let's say, CH3. See, this is an ether group. We haven't learned this, but you don't need to learn it, okay? Because just observe the structure. Here we have a CH3 group. Here we have what? Another CH3 group. Now, previously I told about carbon connected with the same carbon. May use your sense, use your common sense that, and try to understand. This carbon, this CH3 and this CH3, they looks identical. Are they connected with something similar? Yes, they're connected with the like single oxygen atom, isn't it? The same oxygen atom. That means if we think with respect to this oxygen, let's say you are this oxygen. Looking to your left, you see a CH3. Looking to your right, you see CH3. Can you distinguish between them? No, because they look identical. As I mentioned, they don't have any fingerprints. So one chemical environment. I hope you're getting it. Okay, now for the next part, we have what? We have, see, let's try to solve it now without actually drawing the part. Or we can also like draw, because how much time it is going to take? Not much. So CH3, that responded with this CH. There is this CH3. Then we have this CH2, CHOH. Okay. So see, where we have the CH3 group, let's draw with this one. They have the CH3 group and CH3 group. They are identical and connected with the same carbon. Fine. Here we have a hydrogen, that means a different group, because this is not a CH3. It's a different like group of hydrogen. Here we have a CH2 group. Now here we have another CH2 group, but see, like you might say, okay, this is identical to this one, but try to guess, try to observe. You also need to, like, before you, like, let's say you were somewhere in the middle and you get lost. Are you going to say just completely closing your eyes and yes, I'm lost, I'm looking at one side and I'm lost? You should see on the left side as well, isn't it? You have to see backward, like you have to see around to visualize, okay, in which atmosphere, in which position I am. So for this CH2, see to the right, we have a CH2 group. See to the left, we have different group like CH, CH3, CH3. Now, for the next group, this CH2 group, see to the right, we have what? A OH group, a different group, another different group. To the left, we have CH2 group. Yes, for both of them, in one side, we have CH2 group. For this group, we have on the right, we have a CH2 group. Fine. For this CH2 group, on the left, you have a CH2 group. Fine, that's also fine. They have identical, like sort of like partial identification that they resemble, that each are beside each other. But on the other side, we have a OH group, and for this curve, like this CH2 groups, other side, we have what? A different group, a completely different group. That means what? We can say this CH2 is a completely new CH2. Did you get it? We have to see the environment where we are. That's why they are known as environment. What is the environment? Is the environment same, or is the environment different? For this CH2, the environment is different. It's totally different, because in one side we have CH2, in the other side we have some other group, isn't it? That means the environment is different. Like you have, let's say, like in one situation, let's say you have your, how do I say? You have your, let's say, your study table on the right side, and let's say your cousins are speaking on the same room on the left side, okay? In one situation. In another situation, let's say you have the study table on the left side. That's completely fine. We have the study table, but on the right side, instead of your cousins talking, now let's say you are in a conference hall room, you are seeing this thing, like trying to make sense. I know that wasn't a valid or logical example, but that's how it is, isn't it? And finally, we have what? We have, let's say, this another group. I'm running out of shapes. So this is 1, this is 2, this is 3, this is 4, and this is 5. So how many total environments? 5. Okay. Moving on to the next one. We have this Cl. Remember, how many groups here? 0 environments here. Why? Because no hydrogen is there. Okay, so the only thing we are concerned is with hydrogen. So this is one of them. So let's mark it with a different color. This is hydrogen, and for this carbon we have this hydrogen. So that means in total 2 chemical environments. Now for the last one, we have what? Remember, Br is not going to get counted, F is not going to get counted, and Cl is not going to get counted. So we have this as an environment, this as an environment, this as an environment, and finally this as an environment. So how many environments in total? 4 chemical environment. Okay. So you got the portion. Now, coming to the next part, we have this hexane. Now, why did I left it behind? Now things will be easy for you. Try to make sense. Actually, what is the structure? This is a hexane. This is not a benzene, remember? Because we don't have a ring here. That means, how does the structure looks like? We have H here, the imaginary hydrogens here. Now it's your duty to find how many environments are there. It's your homework. It's your homework to find how many environments are there, okay? You have to do it. Similarly, also see, this is benzene, and each carbon has what? Imaginary hydrogen. Okay, here is also your duty to find how many environments are there. It's your your homework to find for each of them. Number 9 and number 11 are your homework to find actually what are the, like, how many environments do they have. Okay, remember to do it. Don't forget, because these two are one of the most important examples, and that's why I left them behind, so that after solving each of the criteria, like all the examples we solved so far, they're enough for your knowledge now. Okay, but before solving the rest of, like, up until 17, you wouldn't have able to solve number 9. Okay, I made it easy for you, so try to solve number 9 and 11 by yourself. Okay, now moving to the next part, we have some mathematical equation calculation. Okay, so whenever, like, we will be given some graphs. Okay, we'll be given some graphs. Before that, we have to know about a formula. So the formula is to find the groups of peaks and number of peaks. Okay, so number of peaks is equals to n plus 1. Okay, where n is number of H atom to the adjacent C atom. That means number of hydrogen atom adjacent to the carbon atom. Because why do we need this formula? The formula is what? N plus 1. Number of peaks equals to n plus 1, where n is the number of hydrogen. We'll be given this sort of graph. That's why it is HNMR. So let's say here the axes are marked 2, 4, 8, 6, 10, 12. Okay. Now let's say we have 0, 2, 4, 8, 6, 8, 10. 10, and we have 12 here. So let's say you will be marked here with, let's say one is here, another is this portion. Now, based on this scenario, you have to identify how many groups are there, how many peaks are there. Sorry, there's another one left, which is this one. So what can you see? This is one group. Why? This is one group because they are clustered. Like, how do you represent group? In school days, yes, you most probably have seen, let's say, 3 boys together, 4 girls together. Like they're forming specific group. That's how we know that's a group. So this is a specific group clustered together. That's another group. And also you have seen, if you are like me, then you'll see, you'll be one alone without any groups, trying to be part of every groups. So now that means in total what? 3 groups, 3 total groups. That means we have 3 environments, 3 chem environments. Okay. Now that means since we have these 3 total environments, we will be using the formula we have here, this n plus 1 formula, in order to find how many carbons, how many hydrogen, like how many hydrogens are there. Okay, so that will be our next class topic. So remember to do the homework by yourself, the homework of number 9 and 11, and the rest will be continued from the next lecture. Okay, take care. Allah Hafiz. Assalamu alaikum.